In this lesson, we're going to go over the types of arcs: arc measure, arc length, and central angles. So we'll start with central angles. So a central angle is formed by joining two radii with a vertex at the center of the circle. So you're going to have two radiuses joining to have a vertex at the center. So this would be a central angle because I have this radius here and this radius here, and they join at the center. So that's a central angle. So it's formed by just joining two radiuses together, and you would have to make an angle. So arc measure. Arc measure is always measured in degrees, and it's the measure of the corresponding central angle. So for example, if I have this radius and this radius joining to form a 124-degree angle, then along the circle, when we say arc, we're talking about this part of the circle. This measure, so we would call this BC or CB, this measure would be, so we would say BC is 124 degrees. So the arc measure is just the measure of whatever angle that was. Three more examples down here is this half a circle has a measure of 180. So this arc measure would be 180. In this next example, this has a measure of 90. So this arc measure here would be 90. In this example, the measure of this angle here is 30. So the measure of that arc is 30. So that's how you find arc measure. It's just going to be the measure of that central angle. The sum of all the central angles in a circle is 360 degrees. So if I was to add this angle plus this angle plus this angle plus that angle, I would get 360 degrees. So if I add up all those angles in a circle, I will get 360 degrees. So the kinds of arcs, there's three types of arcs in a circle. There's a minor arc, there's a semicircle, and there's a major arc. So let's first look at a minor arc. So a minor arc is going to have a measure that is less than 180 degrees. We name it by using the two endpoints. And the measure of a minor arc is the measure of its central angle. So in this example down here, we would name this red arc from here to here. We would name this arc AC with like a little arc over it. So this will be called arc AC. The measure of arc AC would be X degrees because that's what this angle measure here is. The second type of arc is a semicircle. So a semicircle basically is just half of the circle. The measure of a semicircle is 180 degrees. We name it by two endpoints and any other point on the arc. So for example, here I have EG. This splits the circle directly into two. So my arc is this top red part. So it's this piece. So if I want to name this arc, I would say this is arc E. So start with E, then F, and then G. So your endpoints have to stay at the end, and we would put a little arc over it. The measure of this arc is 180 degrees because this is a half of a circle. The last type of arc is a major arc. So a major arc has a measure that is greater than 180. We name it using the two endpoints and one other point. So you need 3 points to name the major arc. The measure of a major arc, so if we want to find how big the measure is, we're going to do 360 minus the measure of the included central angle. So in this picture, the red part is your major arc. So this is the arc that they're looking at. We would name this arc as A, D, C. So your endpoints have to stay at the ends. So this is arc ADC. And if I want to find the measure of arc ADC, so I'll say measure of arc ADC is going to be 360 minus the measure of the central angle, so minus x. That will get you the length of your arc. So example 1. So find the measure of arc TBC in circle P. So here's arc TBC. Notice that if I was to draw the line from T to D, notice that this arc would be bigger than 180 degrees. So from T to B to D would be 180. If I go all the way to C, I'm more than 180. So I know that this is a major arc. So what I'm going to do is to find the measure of the major arc, I'm just going to do 360 minus the central angle that I'm given. So I'm given the central angle 129. I'm given this. So I'm going to subtract 129. And that's going to give me the measure of that arc. So 360 subtract 129 is 231. So this would be 231 degrees. Example 2, find the measure of angle EOF for circle O. So this time what we're given is we want to find EOF. So we want to find this angle right here. We're going to use what we know about angles. Particularly, we're going to use the vertical angles are congruent. Remember, vertical angles are angles that look like this. So these would be vertical angles. Angles that are share a vertex and are directly across from each other, those have the same measure. So here, in my picture, notice I have EOF. Well, the angle on the opposite side of EOF, but sharing this vertex O, is JOH. These angles would have the same measure. So it'd be nice if I knew what one of these angles were. Notice I have that from J to H, I have this arc length is 66. Remember, the arc length is the same as that central angle. So this red central angle is going to be the same as this arc length. So this will be 66. So I know that angle JOH is congruent to angle EOF. And why do I know that? Because these are vertical angles. So angle JOH is 66 degrees. And how do I know that? Because this arc length is 66 degrees. So that means the measure of angle EOF is also 66 degrees just by vertical angles. So example 3, find the measure of arc CD in circle P. So what we know is here is CD. It's right here. We know that this is going to obviously be less than 180 degrees, so this is going to be a minor arc. And what we want to figure out is we want to figure out what this angle measure is here. I'm just going to call it X, because that is going to allow us to figure out what CD is. So thinking about angle pairs, notice I have X and 120 forming along this line, TD. When I have two angles that form along the same line, that means those angles, so two angles forming along a straight line, add up to 180. So what I would say is X plus 120 equals 180. And I would solve this for X. So I'm just going to subtract 120 from both sides of the equation. So this would be X equals 60. So I know now that this angle measure here is 60 which means my arc length is also 60. So I would say the measure of arc CD is 60 degrees. And why is it 60 degrees? Because the measure of the central angle is 60 degrees. I know that the measure of the arc is also 60 degrees. So the next topic is arc length. Arc length refers to the length of a part of a circle. So you can think of it as being part of the circumference. So for example, this red line right here is only part of your circle. It's only part of the circumference. It's not the whole circle. We measure arc length using units. So for example, feet, inches, meters, etc. So we're no longer looking at angle measure, we're looking more at length. So we're going to be using units such as feet, inches, and meters. So let's look at a formula for arc length. So to figure out arc length, there's a formula. So if I want to know the arc length, we have labeled the arc S, but we could just call it arc length would be fine. So what we would need is we would need to know this central angle, and we would either need to know a radius, such as in this picture, or a diameter. So I want you to recall the two circumference formulas that we have, because we're going to use them in our arc length formula. So the circumference formula, remember there was two of them. The circumference is pi times the diameter, or 2 pi times the radius. So if you have the diameter, you're going to use pi times d. If you have the radius, you do 2 pi r. So the arc length formula is down here at the bottom. Make sure you copy this down. So the arc length is going to be the measure of the central angle divided by 360 times the circumference. And the circumference formula that you'll use will depend on what information you're given. If you're given the diameter, then you're going to use this one. If you're given the radius, then you'll use that one. So you use 2 pi r if you're given the radius. So let's just go ahead and look at an example. So make sure you have this formula copied. So example 4, find the length of the arc shown in red. Leave your answer in terms of pi. So we want to find this arc length right here. So let's look at what we know. We know this arc length is 60 degrees. That means the central angle is 60 degrees. So if I want to figure out what this angle is, what I will do is I will just do 180 subtract 60, and that will give me the measure of that angle. So this will be 120. So I know this measure of this angle is 120 because I have two angles forming along this straight line, which is the diameter. So it's another thing is I know that this straight line is my diameter is 78 feet. So let's go ahead and now copy down the formula for calculating a arc length. So the arc length equals, and I'm going to say central angle divided by 360 times the circumference. Well, we know that we're given the diameter, so my circumference is going to be d times pi or pi times d. So this is the circumference. I'm just plugging in my circumference formula right here. So now I'm just going to plug in my information. So the central angle is 120. So I'm going to do 120 divided by 360 times d, which is 78. So I'm going to write 78, and I'm going to have pi. So when I plug this into the calculator, I'm going to plug everything except for pi. So I just want to plug in 120 divided by 360 times 78. So I'm just doing this in the calculator. So when I multiply 120 divided by 360 times 78, I get 26. And then I'm leaving pi in my answer because they said leave your answer in terms of pi. And this was feet. So my answer here is 26 pi feet. Example 5, find the arc length of the arc shown in red. Leave your answer in terms of pi. So here's the arc that we're trying to find, is this one right here. So let's identify what we're given. We know that this length here is 18. This is a radius because it doesn't go all the way across the circle. So this is 18 meters for my radius. Then I also know that this arc here is 25, which means this angle is 25. But using our properties of angles again, we can say that these are vertical angles, so this is 25 degrees. So I know my angle is 25 degrees. So we can say the central angle is 25 degrees. So now let's just write down our arc length formula. So we know arc length is the measure of the central angle. So I'm going to write central angle over 360. And this time I was given the radius. So for my circumference, I'm going to multiply by 2 pi r. So this is the circumference. Now I'm just going to plug in what I'm given. So I know the central angle is 25. So this will be 25 over 360 times 2 pi, and the radius we know is 18. Now I'm just going to plug this into my calculator. So what I'll do is I'll do 25 over 360. And then I'm going to multiply that by 2. So times 2. And I'm going to multiply that by 18. So this number here. And notice I'm not doing anything with pi because they asked me to leave my answer in terms of pi. So this will be 2.5 pi. So that would be my answer. And this would be in meters. So 2.5 pi meters. So that's the answer for this one. So you should be able to complete the Math Excel assignment called Central Angles, Arc Measure, and Arc Length.